All right, can I have everyone's attention? We're going to get started of our last lecture of the day. Congratulations, you guys, for making it almost to the end. I know that sitting in 26100 from 11 to 3 is kind of a marathon. So thank you, guys. Y'all are amazing. So the way this lecture is going to work is it's on basic JavaScript. We're assuming that most of you guys are coming from a background where you have some programming experience in a language like Python, because that's what most of the MIT classes teach. And most of you guys are probably not going to have experience with JavaScript specifically. So this lecture is designed with people from that background where we're just going to quickly blaze through a bunch of JavaScript syntax, and then you can just sort of look at the slide, map it into mentally how it lines up with what programming you already know, like, oh, this syntax is a little bit different in this way. And then you should be good to go. But if you have no programming experience at all, this might be a little bit fast for you, in which case we recommend a resource, which is going to be linked on our website, that will go through the basics of coding in JavaScript more step by step. So if all of this flies over your head, don't worry. Just go to that resource after class, and then you'll be able to get caught up. So earlier we talked about HTML and CSS, HTML being sort of the bones of what your website actually has in it, and then CSS being the presentation of it, making it pretty, etc. Now, how JavaScript fits into this picture is if HTML is the bones and CSS is like the clothing and stuff, then JavaScript is like the organs and muscles that make everything work. So JavaScript is a programming language that takes the content of a web page and manipulates it. So it's what allows the website to change as you're interacting with it. And it's used by basically every website in existence. And it is not related to Java. Please just note. So where we run JavaScript code is there are a few places we can run it. Later today, before class tomorrow, you guys are going to need to install Node.js, which is a program that allows you to run JavaScript on your own machine. But all of our web browsers know how to run JavaScript. So if we want to run JavaScript, and if you want to play around with it, I'd recommend opening up the console. So you can do that by going to Inspect Element here, opening up here, and then the console is going to be one of these tabs here. And then in the console, I can type in any sort of JavaScript I want. I can print something. That's a typo, but whatever. And I can do math. 2 to the power of 3 is 8, etc. I can run any JavaScript that I want in the console here. And so for the time being, we'll be using the console to just play around with it. Feel free to open up your computers, open up the console, and just play around with things as I'm going through the syntax. So now back to actual JavaScript. JavaScript has 5 primitive data types. So if you notice in some languages, such as Java, they make a distinction between int and float, like integer types and ones with decimal points. JavaScript does not. So everything is just a number, or a Boolean, true or false, string, or JavaScript has these 2 funky types called null and undefined. We will get into what those are later. They're a little bit tricky. For operators, things pretty much work exactly as you would expect. You can add, subtract, multiply, raise something to a power, divide, and concatenate strings. But the thing that doesn't work exactly as you would expect from most other programming languages is comparing things. So if you want to compare whether 2 things are equal, typically in JavaScript we use the triple equal sign, or if it's not equal, the exclamation point and 2 equal signs. So in most programming languages, we would use double equal sign to compare whether 2 values are equal. And JavaScript does have the double equal sign operator. But, so question, 2 double equal sign 2, is that true or false? Open hand true, closed hands false. Yeah, it's not a trick question, it's true. What is this? True or false? OK, I'm getting a big mix, like maybe half and half for true and for false. So in most programming languages, we kind of want this to be false. Because if we have 2 things of different data types, those are different entities in memory. We can do different things with them. But in JavaScript, it doesn't do this. In JavaScript, 2 double equal sign 2 as a string is true because JavaScript performs type coercion, so it just converts one of the types to be the same as the other type before it compares them, which is generally what we don't want in programming because it causes a lot of unpredictable behavior. And so in JavaScript, basically the bottom line is we always use triple equal sign when comparing things. All right, let's go over some pretty basic syntax. JavaScript has a semicolon at the end of every single statement. So any command that you do ends in a semicolon. It doesn't matter whether you indent things properly or not. So if this was a complete garbage mess with no indenting whatsoever and white space all over the place, JavaScript would be able to execute it just fine. But please indent things properly for readability. You use curly braces to denote where blocks begin and end. So in Python, you would have a function, the function signature, and then a colon, and then an indented block. In JavaScript, it's different. You use an open and closed curly brace to indicate that block. And similarly for loops. And then you can make comments using the double slash. So in JavaScript, defining variables is kind of different from how you would have done it in most other languages. The standard way of defining variables is by using the keyword let. So you use let, your variable name, and then you can set it equal to something. Convention for naming variables is camel case. So if you're like me, you will start coding in JavaScript and then use the snake case with the underscores and everything. And then you will be sad because your code base is not up to JavaScript convention. So use camel case. So normally we use let, but if we have a variable that we don't want to be able to reassign later, we use const. So if we say const answer to life equals 6148, that's the old course number for weblab, and then we try and reassign this variable to something else, JavaScript will give us an error. You might ask why we bother using const at all, because let just does the same thing, but it's generally safe code practice to define something as const if you know that you're not going to want to change it, so that if things change later, JavaScript gives you an error, you know something's wrong. And then there's also another keyword that you can use to define variables in JavaScript. It's called var. If you Google around, you might see code that uses this. Basically, just don't use it. We don't use that anymore. Technically speaking, var is function scope. So a variable defined with var exists within the function that it was defined in. But that is very different from the way any other programming language works, where your variables are typically block scoped, defined within whatever curly braces they're defined in, or that exist within whatever curly braces they're defined in. And so just don't use var. It's kind of sad. Any questions on what we've gone over so far? All right. So null and undefined are two things that you might not have seen before. Undefined means that you have not assigned something a value yet. So you can declare a variable, let first name, and then a semicolon, without assigning it any value. And then JavaScript will automatically assign the value of that variable to be undefined. And alternatively, we can also use null to explicitly say there is no value for this variable. And yeah, if in the purposes of your code, you want to know whether this variable has like no value. Pretty simple. Console.log prints something. And it's good for debugging, so you can put console logs all over your code, and then it'll print out things that are useful for you to know. Oops. OK, JavaScript also supports template strings. So if you want to, normally you would define a string using the quotation marks, regular quotation marks. But if we define a string with the backtick, which is in the top left corner of our keyboard, then we can put in little bits like this that have the $sign and then curly braces. And then inside those curly braces, we can put any JavaScript expression we want. So basically, this will evaluate this JavaScript expression, multiply these two variables together, and then stick that right into the string. So these are called template strings. Another way of debugging, if you want, you can use an alert, which will generate a pop-up on your web screen. OK, Any questions on what we covered so far? Sorry, we are just like blazing through this one thing at a time. All right, so for arrays, this is pretty similar to lists in Python or whatever, but we can fill our array with literally anything we want. Remember that in all programming languages, arrays are 0 indexed, which means that the first index, if we want to get out the element at index 3 of pets, which is what this is doing, then this is index 0, this is index 1, index 2, index 3. So this one is bird. This is not index 1. And then we can replace an element of our array with whatever we want. So if we want the element at index 2 of pets to be hamster, then we go index 0, 1, 2, replace that with hamster. Any questions on this? OK. And then another thing we can do with arrays in JavaScript that's kind of unique to JavaScript is push and pop. Push allows you to just add something directly to the end of the array, and pop takes something off of the end of the array. So here, we're popping off, we have cat, dog, guinea pig, and bird. We're going to pop off the last element, which is bird, and now our array looks like this. And then we're going to push rabbit onto the end, and so now our array looks like this. Questions? OK. Conditionals work as pretty similarly to every other language. We have if, else if, and else. So if whatever value is stored in our variable hour is less than 12, it'll print this. But if it's not less than 12, then it will go on to the next statement here and check if that is true. If it's not less than 12 but less than 16, then it'll print this. And then if it's not less than 12 or 16 but less than 20, it'll print this. And then finally, if it's greater than 20, it'll print this. OK. An indentation is good but not necessary for your code to work. While loops, also pretty familiar. You can define some kind of variable and then perform an action as long as this variable is satisfied. So if we set z to be 1, then it'll go here, check if this condition is true. If it is, which it is because z is 1, then it'll go execute what's inside of here. And then come back up here, check if the condition is still true. If it is, we execute it again, and so on and so on and so on until this condition becomes false. So this block of code will print everything up until and including 1024, because we console.log it first, and then we go back up and check if it's less than 1,000. And if we want to iterate through an array, we have to do this funky thing, which you will have seen if you're familiar with Java or C or one of these other languages. We define an array, define a index or a variable that contains the index of our array that we're currently looking at. So we'll set it equal to 0. And then we iterate through every index of the array until we hit the length. So if the length here is 4, so this is 4 elements in the array, then I is going to start at 0, and then it's going to keep incrementing until I is 1, 2, and 3. And then once it's equal to the length, because remember the length is 4, then it will stop. So we'll iterate through indices 0, 1, 2, 3, and iterate through the entire array. Any questions on this? OK. And then if you've seen iterating through arrays in Python, this might look a little more familiar to you. This just iterates not through the indices of the array, but through the elements themselves. So we define a variable const animal, and then we say of pets. And then JavaScript will just keep going through and reassigning or redeclaring animal to be the next element of the array. So animal will be, at first, the string cat, and then the string dog, and then guinea pig and bird, etc. Questions on this? OK. And now we're going on to some more complicated stuff. In JavaScript, there are some things that we don't have primitive data types for, more complicated entities that we want to represent in code. And so we can use something called JavaScript objects. This is kind of different than objects in most other languages, most other object-oriented languages. A JavaScript object is more similar to a Python dictionary, because it's just a set of keys and values. And you can access the properties of an object using the syntax that's very similar to a dictionary in most other languages, where you use the square brackets and then the string for whatever the property name is. Or you can use a syntax that's more similar to objects in other programming languages, such as Python, by using the name of the object, which in this case we're defining as a car, and then the dot, and then the name of the property. Questions on any of this? All right. And then something kind of special that you can do in JavaScript is object destructuring. If you want to get multiple properties at once, then you can either use multiple lines like this and just set two variables, make and model, to be whatever we pulled out of this myCar object. Or we can also put these fancy little curly braces here and stick make and model in here, and then this code is exactly equivalent to this code. So it's just a shorthand way of assigning variables to the values in a JavaScript object. And we'll probably be using this a bit in our web programming. OK, so earlier we talked about equality, where we can check if two primitive values are equal using the triple equal sign. However, what does this mean for arrays and objects? So if we have two arrays and we initialize them with the exact same values, but then we do triple equal sign on these two arrays, we get that this is false. Turn and talk to someone next to you why you think this is the case. Yeah? Yes. All right. I'm going to pull it back. So the reason why these are false, as I'm guessing a lot of you know, is that object variables are references. So they point to the location in memory where this is stored. So what we're doing when we say let person1 equal this is we're creating a new object. OK. Oh, wait, sorry. I was going to do this on the board. So when we create a new person1 object, we are creating a new variable in memory, some new object that has name Bill Gates. Sorry, my handwriting is terrible. And then we say person1 is pointing to that. And then on line 2, when we create a new person, we create person2. We're creating another object in memory that also has name Bill Gates. And we have person2 pointing to that. And when we check if person1 is equal to person2 with the triple equal sign, then we're checking, actually, whether the location of memory that person1 is pointing to is the same location of memory as what person2 is pointing to. And they're not, because they're different places in memory, even though they have the same value. But if we were to do something like the code we have here on the bottom, where we say we create a new object with the name Bill Gates, but then we define person2 by setting an equal to person1, then they're pointing to the same location of memory, and this will evaluate to true. And because of that, that also means that copying arrays and objects is not so easy. Because if we had array pointing to an array, 1, 2, 3, and then we set copy array to the array, similar to what we had over there, we have two variables pointing to the same location in memory. And so if we do something like copy array at index 1 is equal to 10 gazillion, then it would update and edit not only copy array, but also array, because they're pointing to the same array in memory. So this will not work. This will make you sad with lots of bugs. But you can copy arrays and objects using the spread operator, which, I mean, what it does is it literally just takes all of the elements of this array and unpacks them, and then we can create a new array or a new object with them. Any questions on any of this that we've gone over so far? Alrighty then, we are moving right along. Last main topic for today, functions. Functions take in an input and do something with it. And sometimes we want it to return an output value, sometimes we don't. The JavaScript function syntax is quite different from what you have seen in other languages. So in JavaScript, there are multiple ways to define a function. So if you go poking around online, you might see different ways of defining a function. But the way that we're going to use for WebLab takes in parameters in parentheses, and then it has a little arrow, and then it has the body of the function in curly braces. And this is kind of nice because it sort of mirrors this diagram that I have above, where we have our function that takes in an input and feeds it into the body of a function to do something with that input. OK. So here's an example of a function definition. It takes in a temperature in Celsius and then feeds that into the body of the function, where we're computing the equivalent temperature in Fahrenheit and then returning it. Any questions on this code? Cool. I'll give you a minute to digest it. All right. And so if I have this function definition, that exactly the same as what I just showed you, the only problem with this is that we can't quite call this function. So just think for a sec, what do we need to add so that we can actually make this refer to this function and call it? Well, for that, we need to add a name. We need to have some kind of way of referring to this function. And so let's say we want to name our function Celsius to Fahrenheit. And so we have this function stored in memory somewhere on our computer in this big gray box. And then we want to have a name or a variable that can point to that location in memory. And so in order to do that, we define a variable and set it equal to the function itself. So const just means that this cannot be reassigned, where in memory this points to, which we don't want it to be. And then this is the name of our variable. We're setting our variable equal to this entire function. And then, of course, there's a semicolon. And so the bottom line of this is that a function is this big gray thing, a value stored in memory, just the same as a string, an int, array, et cetera. So that means that we can assign a variable to point to it. And that's how we give our function a name. And then if we want to call our function, we use parentheses, just like any other programming language, and put in whatever input we want. And then this Celsius to Fahrenheit of 26 will be 78.8. And then that value will be assigned to the variable room temp. All right, and then as a quick preview to the lecture that we're going to talk about, we're going to talk more about this tomorrow. But as a preview, we can pass around a function just like any other value. So that means that we can give a function as an argument to another function, and we call that a callback. So as a quick practice, actually, no, I'm going to skip this for the sake of time. But we have an example of setTimeout, which is a JavaScript library function that calls a function after a certain delay. So this function takes in two parameters, the function to call and the delay. So if I call the setTimeout function, I'm going to say, OK, do this, whatever function I'm passing in, after this many milliseconds. So how can we print our message, call this print something function that I defined at the top of the slide, after 5 seconds? So give me, actually, you know what? Take a minute, look, think about which ones of these are valid. Talk to someone next to you. about which ones of these will work. And raise your hand if you have any questions. I detect general confusion. So could someone raise their hand and ask me to re-explain something about what they're confused about? All right, in that case, I guess I will just keep plowing forward then. So if you think A will work, to give me open hand. If you think it won't work, give me closed hand. OK, I'm getting a mix. All right, A does work. So print something is a variable that holds the value that is this function. And so we're giving this function into the set timeout and saying, call this function after 5 seconds. Give me open hands if you think B works, closed hands if you think it doesn't. Also a mix. So B does not work. So B will call print something. So when you put these parentheses next to your function, that calls it right away. And so we're going to call the function right away, and then take whatever this function returned and pass that into set timeout, which is not what we want, because this function returns like nothing, null, or undefined, or something like that. And raise it open hand if you think C works, closed hand if you think it doesn't. OK. All right. Most of y'all are getting it. C does work, because this function here, defined in C, is exactly the same as the function that we set the variable to print something. So it does the exact same thing. Yes, exactly. It will be a different object, a different function, or like defined in a different place in memory, but it'll be a function that does the same thing. Yes, so don't do B. Don't call your function, and you need to pass in the function itself. All right, seems like y'all got C, so I'm not going to spend time and explain it. But these are two functions that you might find useful in your projects at some point. Set interval calls a function after a delay. Set timeout calls a function at certain intervals. So if we want to call a function every 10 milliseconds or something, we would use set timeout and pass in our function as a callback. All right, this slide is just here so you guys know that classes in JavaScript exist. They're a thing. We're not going to be using them in WebLab, so you don't need to know how they work for the purposes of WebLab. But they exist. OK, and if a lot of this lecture went flying over your head, don't worry. That's very normal. I found this website online that I thought was pretty good. It introduces JavaScript concepts in a pretty beginner-friendly way, and you can go through some exercises to practice. So you can see that afterward. OK, time for feedback. If you can pull out your phones or whatever, or devices, and fill out this form, it only takes 1 minute. That would be much appreciated. I'll give you 1 minute to do that, and then we'll move on to announcements, and y'all will be free. Just look at me and give me a thumbs up when you're done with the feedback form so I know. All right. If you're not done with the feedback form, feel free to continue. But for the sake of time, I'm going to segue into final announcements. So Important announcement is that if you have not done the second part of homework 0 of our setup to install Node.js on your system, you're going to need that for class tomorrow. So make sure to do that. It's super quick. If you run into any issues with setup, or you had run into any issues today that you weren't able to get resolved during lecture, feel free to come to office hours, 7 to 9 p.m. tonight in the basement of the Stata Center right over there. Or if you're new to programming and you just want to talk about it with someone, and we can teach you stuff in office hours. We have a lot of staff. Another thing is team finding. So if you need a team, please join the Zoom, weblab.is/Zoom, or if you're on the Zoom already, then that's great. We will have a little team finding mini mixer in like a couple minutes. And then finalizing your team and brainstorming and submitting 10 ideas for your website is due by the end of the day on Wednesday. So just have that on your radar. And for recordings for today, you will have that posted as soon as we edit and finalize things. But you should be able to, I think you should be able to see the live stream still on YouTube, like right after this is over. And then it should also be available on Panopto, on weblab.is/Panopto. We'll send out that link as well. Yeah. OK, so if you need to find a team, feel free to stay here and just hop on weblab.is/Zoom. Do you have any other announcements?
Yeah, thanks, Abby. A few more announcements. We have a few extra shirts from last year. It's free merch. You can go up to the top where Stanley and Daniel are to pick up free shirts. And there's also extra pizza. So if you want extra pizza, take it, please. We're otherwise left with a lot of pizza we don't know what to do with.